Picture this, a stone fortress rising from a rugged coastline, its walls not just defying attackers, but defying time itself. Inside, intricate channels carry water through sun-baked courtyards, while hidden iron reinforcements hold arches and vaults in perfect balance, centuries before such techniques became commonplace. This isn't a scene from a fantasy novel, it's the real, tangible legacy of the Knights Templar, a brotherhood of warrior monks whose engineering brilliance reshaped the medieval world and quietly laid the groundwork for modern civil engineering as we know it. We often imagine the Middle Ages as a period of stagnation, a so-called Dark Age waiting for the Renaissance to bring it into the light. But what if I told you that some of history's most revolutionary innovations in construction, metallurgy, and infrastructure were already happening forged in the fires of faith, conflict, and astonishing ambition? Today, we're pulling back the curtain on one of history's most fascinating and misunderstood organizations. The Knights Templar were far more than holy warriors or keepers of mysterious secrets. They were visionaries, master builders, and practical engineers who transformed raw materials like iron into tools of lasting change. In an era where many structures were built to last a generation, the Templars built for the ages. They designed castles that doubled as economic hubs, engineered water systems that turned deserts into habitable strongholds, and shared knowledge across continents in ways that would make any modern innovator take notes. Their story isn't just about stone and metal, it's about how human ingenuity, when driven by purpose and resources, can leapfrog the limitations of its time. So join me on a journey back through the centuries, to a world where faith and function met in stone and iron, where the clang of the blacksmith's hammer echoed not just in weaponry, but in the very skeleton of civilization. We'll explore how the Templars turned iron into innovation, how their designs influenced everything from Gothic cathedrals to modern reinforced concrete, and why their legacy still matters in today's conversations about sustainability, durability, and intelligent design. This is a tale of hidden marvels, borrowed wisdom, and engineering triumphs that have long been waiting just beneath the surface of history, ready to inspire us all. In the year 1119, a small group of 9 knights, led by a French nobleman named Hugues de Payens, made a vow to the King of Jerusalem. Their mission was deceptively simple yet monumentally dangerous: to protect the growing stream of Christian pilgrims traveling to the Holy Land. These travelers faced bandits, harsh terrain, and the ever-present threat of conflict on the roads between the Mediterranean coast and the sacred city of Jerusalem. This humble beginning, under the official name of the Poor Fellow Soldiers of Christ and of the Temple of Solomon, gives little hint of the engineering powerhouse they would become. Their initial home was on the Temple Mount, believed to be the site of King Solomon's temple, which is how they earned their famous name, the Knights Templar. What set them apart from every other military order of the time was their revolutionary dual identity. They were not merely warriors, they were also monks, bound by a strict religious rule that required prayer, poverty, and obedience. This combination was their greatest strength. As monks, they were part of the church, earning the trust of popes and kings, which led to immense donations of land, money, and resources across Europe. As warriors on the front lines of the Crusades, they were constantly exposed to advanced knowledge from Byzantine and Islamic cultures, who were centuries ahead of the West in mathematics, architecture, and metallurgy. They became a sponge, absorbing the best technical and intellectual ideas from every corner of the known world. This unique access to both immense wealth and cross-cultural expertise is the key to understanding their engineering genius. The Templars quickly realized that to fulfill their mission of protection, they needed to build, and not just simple forts, they needed self-sufficient, formidable strongholds that could withstand long sieges, house large garrisons, and manage complex logistics. Their spiritual duty to provide safety seamlessly merged with a practical need for innovation. Their building projects became acts of devotion, constructing not only defenses but also hospitals, roads, and bridges for pilgrims. This practical piety fueled an ambition to build better, stronger, and more efficiently than anyone else, setting the stage for a civil engineering legacy that would far outlast their military exploits. But to truly grasp the scale of their ambition, we need to look beyond their origins and into the very materials that made their vision possible. For the Templars, iron was not just a metal for swords and armor, it was the hidden skeleton of their entire civil engineering empire. While other medieval builders relied almost exclusively on stone and timber, the Templars saw in iron a versatility that was centuries ahead of its time. Their extensive network of commanderies and preceptories gave them access to some of the best iron ore deposits in Europe, from the mines of Lorraine in France to those in the Iberian Peninsula. They didn't just acquire raw material, they mastered its entire life cycle from extraction to forging, employing techniques that were remarkably sophisticated for the period. One of their most revolutionary applications was in masonry. In an age where the immense weight of stone ceilings and vaults was held up by sheer mass and careful balancing, the Templars introduced iron as a tensile force. They would embed long iron bars, often twisted for extra grip, within the stonework of arches and vaults. This acted as a primitive but highly effective form of rebar, counteracting the outward thrust of the stones and allowing them to build taller, wider, and more stable interior spaces. At their great fortress of Shaytau Pelerin in the Holy Land, for example, investigators have found evidence of iron cramps and tie rods used to lock massive stone blocks together, significantly increasing the structure's resistance to earthquakes and siege engines. This wasn't just building, it was a fundamental reimagining of how to make stone behave. Their innovation extended to the tools themselves. Templar blacksmiths, likely learning from Islamic metalworkers who were unparalleled in their mastery of steel, perfected methods of quenching and tempering that produced tools of exceptional durability and sharpness. Imagine an iron-tipped drill that could bore into hard stone long after a competitor's tool had gone dull, or a tempered steel chisel that allowed for more precise and intricate stone carving. This directly translated to efficiency and allowed for a level of detail and scale that was previously unattainable. Their superior axes and saws also revolutionized their use of timber, enabling them to shape stronger beams and construct the complex scaffolding needed for their most ambitious projects. This strategic embrace of iron fundamentally changed what was architecturally possible. It allowed them to take calculated risks, designing structures with larger windows for better light and ventilation, or thinner walls that used less material without sacrificing strength. This approach reveals a mindset that was deeply practical and results-oriented. They were not building for tradition's sake, they were engineering for maximum efficiency, durability, and functionality. Their use of iron became the critical, if often invisible, ingredient that set their buildings apart, creating a legacy in stone and metal that would endure long after their order was gone. But to see this genius fully realized, we must step inside their most magnificent creations, their castles and commanderies. These structures were far more than mere buildings. They were complex, multifunctional machines designed for living, working, and worshipping, all while projecting an aura of impregnable strength. Perhaps no single site better encapsulates this than Shaytau Pelerin, also known as Atlet Castle, their formidable stronghold on the coast of the Holy Land. Built in just a few short years starting in 1218, its construction was a staggering logistical feat. What made it so revolutionary was its seamless integration with the natural landscape. The Templars didn't just build on a cliff overlooking the Mediterranean, they built with it, using the sea itself as a moat on three sides. The landward side was protected by two massive, concentric walls, an early and highly effective example of a concentric defense system that forced attackers to breach not one, but two separate rings of death. Within these walls, the layout was a masterpiece of efficient design. The inner bailey housed the spiritual heart of the castle, a 12-sided church, living quarters for the knights, and a huge refectory. The outer ward was a bustling hub of industry with stables, workshops, forges, and even a market, but the true engineering marvel was its water supply. The castle featured an advanced system of rainwater collection channels feeding into not one, but three enormous underground cisterns carved directly into the bedrock. These could hold enough water to sustain a garrison of over 4,000 men through a siege lasting years. This wasn't just a fortress, it was a self-sufficient city, a statement of permanence and power engineered to endure. Back in Europe, this same philosophy of integrated design was applied to their vast network of commanderies. These were not grim, militaristic compounds, but rather the economic engines of the order, and their architecture reflected this purpose. A typical commandery was a carefully planned complex, often arranged around a central courtyard. You would find a chapel for worship, a dormitory for the brothers, a large chapter house for administrative meetings, and extensive agricultural buildings, granaries, barns, bakehouses, and breweries. The layout was always pragmatic, minimizing unnecessary movement and maximizing productivity. Storage was a particular priority. Their granaries were often raised on stone saddle stones to protect the vital grain harvest from damp and rodents, a simple yet highly effective innovation. What truly set these commanderies apart was their holistic approach to sustainability. They were designed as closed-loop systems long before the term existed. Waste from the stables would be used to fertilize the fields. Water from their sophisticated drainage systems would be channeled to irrigate crops or power mills, and the heat from the bakery's ovens might even be used to warm adjacent buildings. This wasn't just about cost saving, it was a deeply ingrained principle of resource management born from their monastic vows of poverty and self-sufficiency. Their buildings worked in harmony with their function and their environment, creating a model of efficiency that was centuries ahead of its time. The commandery was a physical manifestation of the Templar ethos, orderly, disciplined, resilient, and utterly purposeful, proving that their architectural innovation was matched only by their visionary approach to how a community could truly thrive. Yet this mastery of water extended far beyond the arid battlefields of the Holy Land, finding equally brilliant application in the rain-soaked landscapes of Europe. Here, the Templars shifted their focus from survival to productivity, harnessing water not just as a resource to be conserved, but as a powerful force to be exploited. Across their vast European estates, they became pioneers of hydraulic industry, constructing sophisticated water mills along rivers and streams. These weren't simple grain mills, they were multi-functional industrial engines. Templar mills were used for fulling cloth, a process of thickening woolen fabric that was essential to the medieval textile trade, for tanning leather, and for operating trip hammers in their forges to work iron. This integration of water power into their economic model was a stroke of genius, turning the natural flow of a river into a relentless, tireless source of mechanical energy that operated around the clock. dramatically increasing their production capacity and, by extension, their wealth. The true sophistication of their European water management lay in their manipulation of the entire watershed. They didn't just build a mill on an existing river, they engineered the environment to serve them. They constructed complex networks of leats, artificial channels, to divert water from its natural course and deliver it to their mills with greater force and control. They built weirs and sluice gates to regulate flow, ensuring consistent power throughout the seasons. In marshy areas, like their famous commandery at Cressing Temple in England, they implemented extensive land drainage systems, using carefully dug ditches and canals to reclaim waterlogged land for highly productive agriculture. By transforming boggy ground into fertile fields, they not only fed their own communities but also generated substantial surplus crops for trade, further fueling their economic engine. This holistic, almost symbiotic relationship with water reveals the core of the Templar engineering philosophy, a profound understanding of the environment as a system to be worked with, not just conquered. Whether capturing every precious drop of rain in a stone cistern or bending a river to power an industrial forge, their approach was one of meticulous observation and intelligent adaptation. They saw water not as an obstacle or a simple necessity, but as the lifeblood of their entire operation, military, economic, and spiritual. Their ability to manage it with such skill in such wildly different climates stands as a powerful testament to their flexibility and foresight, proving their legacy was built as much by the flow of water as by the strength of stone or iron. This sprawling, interconnected web of commanderies, preceptories, and fortresses was far more than a financial or military network. It was the medieval world's most sophisticated information superhighway. The Templars were arguably history's first truly multinational corporation, and their most valuable cargo wasn't always gold or relics, it was knowledge. A brother traveling from a commandery in Portugal to the headquarters in Jerusalem would carry with him not just dispatches, but mental blueprints, first-hand observations of what worked and what didn't. He might have seen a novel type of water wheel in northern France, observed a more efficient smelting technique in German mines, or marveled at the mathematical precision of an Arabic arch in Acre. This constant, purposeful movement of people created a relentless cross-pollination of ideas, ensuring that a breakthrough in one corner of their empire could be rapidly tested and adapted in another. Their unique position on the cultural front lines of the Crusades gave them unprecedented access to advanced knowledge that was utterly unknown in the feudal West. While European lords were often building with thick walls and small windows, the Templars were studying the airy, light-filled structures of their Byzantine and Arabic counterparts. They saw firsthand the structural advantages of the pointed arch, a staple of Islamic architecture that distributes weight more efficiently than the rounded Romanesque arch, allowing for taller buildings and larger openings. They observed the genius of the ribbed vault, which concentrates the load of a ceiling onto specific, reinforced points, freeing up the walls for expansive stained glass windows. The Templars didn't just admire these innovations, they reverse-engineered them, blending this Eastern wisdom with robust European construction methods to create a hybrid, uniquely Templar style. This role as knowledge brokers is vividly illustrated in their sacred architecture. Take, for example, the famous Rotunda Church in their Convent of Christ in Thoma, Portugal. Its central plan is a direct echo of the Dome of the Rock in Jerusalem, a structure they knew intimately from their headquarters on the Temple Mount. But they didn't simply copy it, they adapted it, reinforcing it with their own European engineering sensibilities. Elsewhere, in their chapels across France and England, you can find the pointed arch and ribbed vault appearing decades before they exploded into prominence in the great Gothic cathedrals. It's no coincidence that the Cistercian order, known for its own architectural prowess, shared a close relationship with the Templars. Ideas flowed freely between them, accelerating the spread of these revolutionary techniques. This free exchange wasn't limited to grand designs. It extended to the very materials they used. Their metallurgical advances, for instance, almost certainly owe a debt to the superior steelworking techniques of Damascus and Toledo, centers of blade making whose products the Templars would have encountered, traded for, and undoubtedly sought to understand. The recipe for the exceptional mortar used in their coastal fortresses, which has withstood centuries of saltwater erosion, may have been learned from Byzantine masons who had perfected formulas for maritime construction. By acting as a conduit, the Templars didn't just hoard this knowledge for themselves. They inadvertently acted as a cultural transfer mechanism, slowly filtering the accumulated engineering wisdom of the ancient and Eastern worlds into a Europe that was on the cusp of its own great architectural awakening. Their network ensured that innovation was not a local secret but a shared resource, accelerating the technological progress of an entire continent. All of this innovation, the iron reinforcements, the hydraulic systems, the architectural borrowing required something just as revolutionary to make it possible, an almost unimaginable amount of money. The Templars' engineering ambitions were not funded by occasional windfalls, but by a sophisticated and relentless financial machine that made them the wealthiest institution in the Christian world after the papacy itself. Their economic power became the essential fuel for their technological fire, granting them a freedom to experiment that was simply unavailable to kings, lords, or even other monastic orders who were bound by tradition and limited coffers. The sources of their wealth were as diverse as they were brilliant. It began with pious donations. As their reputation for piety and military prowess grew, noble families across Europe gifted them vast tracts of land, entire villages, and lucrative rights to tolls, markets, and mills. A knight joining the order might donate his entire estate. A grateful nobleman praying for a relative's soul might bequeath a profitable vineyard. This steady stream of charitable giving provided a solid foundation of assets, but the Templars were far more than passive landlords. They actively managed these holdings with a businessman's eye for profit. Their European commanderies became highly efficient agricultural centers, producing enormous surpluses of wool, grain, and wine that were sold at market, generating a continuous and growing income. Their most ingenious financial innovation, however, was their development of international banking. Pilgrims traveling to the Holy Land faced a terrible risk. Carrying a purse of gold on a months-long journey through bandit-infested lands was an open invitation to be robbed and left destitute. The Templars provided an elegant solution. A pilgrim could deposit his cash at a Templar commandery in London or Paris and receive an encrypted letter of credit. He could then travel to the Holy Land, present this letter at the Templar treasury in Acre or Jerusalem, and receive the equivalent value in local currency, minus a small fee for the service. They had effectively invented the traveler's check. This system not only protected their clients but also meant that vast sums of money were constantly in transit within the Templars' own network, money they could leverage to fund their building projects years in advance of the actual tax revenues coming in. This immense and liquid capital is what separated them from every other builder of their age. A king might have to wait for tax revenues or ransoms from prisoners to fund a castle, causing construction to start and stop for years. The Templars, with their deep reserves and credit systems, could plan and execute projects on a grand scale without interruption. They could afford to hire the most skilled master masons from France, the best German metallurgists, and the most innovative hydraulic engineers from the Arab world, creating dream teams of medieval craftsmanship. They could commission the highest quality iron from specific mines known for their pure ore, and they could pay for the most durable, fine-grained stone to be quarried and transported over great distances. This financial muscle allowed them to take calculated risks that others couldn't. They could experiment with a novel vault design, and if it failed, they had the resources to tear it down and try again. They could invest decades in a single, monumental project like Shaytau Pelerin, confident that their financial engine would continue to fund it to completion. Their wealth was never an end in itself. It was the ultimate tool, the essential enabler that turned their boldest engineering visions into enduring stone and iron reality. Yet for the Templars, a building was never merely a functional shell of stone and mortar. It was a prayer made physical, a theological statement etched into the very landscape. Their engineering genius was inextricably woven with a profound layer of religious symbolism, transforming their structures from simple shelters into profound expressions of their divine mission. This was architecture as an act of worship, where every measurement, every alignment, and every geometric form was imbued with spiritual significance, creating a hidden language of faith that echoed their unique identity as warrior monks. To walk through a Templar chapel was to navigate a map of their celestial aspirations, where the practical and the sacred became one. This symbolic intent is most powerfully revealed in their meticulous use of sacred geometry, particularly their reverence for the circle and the octagon. The circle, a shape with no beginning and no end, was a universal symbol of God's perfection, eternity, and the heavenly realm. We see this echoed in their famous round churches, like the Temple Church in London or the Rotunda at Thoma. These were not arbitrary designs. They were deliberate references to the Church of the Holy Sepulchre in Jerusalem, the holiest site in Christendom and the very heart of their founding purpose. By replicating this form across Europe, they created a continuous architectural thread connecting their outposts directly to the spiritual epicenter of their world. The octagon, an intermediary shape between the earthly square and the divine circle, also appears frequently, perhaps most famously in the Charola of the Convent of Christ. This eight-sided design is rich with meaning, symbolizing regeneration and resurrection themes central to a knight who faced death daily and believed in eternal life. The alignment of their buildings further reveals this deep symbolic layer. Templar churches were almost universally oriented with the altar pointing toward the east, toward the rising sun and Jerusalem. This standard Christian practice was taken to an extreme of precision by the order, reflecting their direct and intimate connection to the Holy Land. But their considerations went beyond simple compass points. There is compelling evidence that they also aligned certain structures with specific astronomical events, such as the sunrise on the summer solstice or the position of key stars. This celestial choreography would have bathed the interior of a chapel in a specific, dramatic light on certain holy days, creating a breathtaking visual sermon that connected the heavens above with the worship below. It was a way of harnessing the cosmos itself to glorify God, demonstrating a belief that the entire universe was part of a divine, orderly plan that their architecture was meant to reflect. Beyond grand geometries and alignments, the Templars also embedded smaller, more intimate symbols into the very fabric of their stonework. Stonemasons' marks, while often practical identifiers, sometimes took on symbolic forms like the eight-pointed Maltese cross, a variation of their own emblem. More intriguing are the occasional, subtle carvings that hint at their unique esoteric traditions, images of two knights sharing a single horse, a powerful symbol of their initial poverty and brotherhood, or the recurring motif of the lamb carrying a banner representing the sacrifice of Christ. These were not public declarations but quiet affirmations of faith meant for the eyes of the initiated, for the brothers who lived and prayed within those walls. They served as constant visual reminders of their vows and their higher purpose, reinforcing their collective identity in every carved detail. This seamless fusion of faith and function is the ultimate key to understanding Templar architecture. The same mathematical principles that ensured a vault would not collapse the precise ratios and harmonious proportions were also believed to reflect the perfect order of God's creation. The iron reinforcement that allowed for larger windows did so not just for structural advantage, but to flood the sacred space with heavenly light, a physical manifestation of divine illumination. Their advanced water systems, which provided practical sustenance, can also be seen as symbolic of spiritual purification and the living water of faith. For the Templars, there was no distinction between building well and worshipping well. To engineer a stable, beautiful, and efficient structure was, in itself, a profound act of devotion. Their buildings stand as silent sermons, testaments to a world where every stone laid and every beam raised was an integral part of their sacred duty, blending the strength of a warrior with the piety of a monk into an enduring architectural legacy. To understand how all these elements, financial power, cross-cultural knowledge, and symbolic design came together in a single, breathtaking project, we need to journey to the hills of central Portugal, to the town of Thoma. This isn't just another ruin. It is perhaps the most complete and eloquent love letter the Templars ever wrote in stone and iron, a masterpiece where their engineering vision was realized on a staggering scale. Granted to the order in the mid-12th century as part of the Christian Reconquista of the Iberian Peninsula, the site of Thoma was strategically chosen atop a hill overlooking the Nabao River. This was a frontier outpost, a bulwark against the Moorish forces to the south, and the Templars were tasked with both securing the territory and cultivating it. What they built there over the subsequent centuries is a breathtakingly clear window into their unique blend of pragmatic military genius and profound spiritual contemplation. The first thing any visitor to the Convent of Christ, as the complex is known, notices is its sheer layered complexity. This isn't a single castle but a living timeline of Templar and later Manuline architecture, with the original 12th century Templar fortress forming its powerful heart. The defensive design is a textbook example of their concentric principles. The outer walls, studded with robust towers, follow the natural contours of the hill, making any approach by a besieging army a deadly uphill battle under a constant hail of projectiles. Within this first line of defense, the inner curtain wall is even higher and stronger, creating a deadly killing zone between them. But the true defensive genius is in the details. The strategically placed arrow slits, calculated to provide overlapping fields of fire, and the heavily fortified gates that could be sealed with massive iron-reinforced timber and portcullises. Every element of the design was a calculated response to the art of siege warfare, making Thoma a virtually impregnable stronghold. Yet, within these formidable walls, the Templars engineered an oasis of self-sufficiency. Their mastery of hydraulics is on spectacular display in the intricate system of cisterns and channels they constructed. They captured and stored every drop of rainwater, channeling it through a network of stone conduits into vast underground reservoirs. One of these, the Grand Cistern, is an awe-inspiring vaulted hall hewn from the rock, capable of holding enough water to sustain the entire garrison for years. This wasn't just a tank, it was a cathedral to utility, a beautifully engineered solution to the most basic human need, ensuring they could outlast any prolonged conflict. This water management extended beyond survival to industry, likely powering forges and workshops within the complex, turning the fortress into a humming center of production. The absolute crown jewel of Thoma, and the feature that perfectly encapsulates the Templar spirit, is the Charola, the original 12-sided oratory. Stepping inside this rotunda is a transcendent experience that instantly dissolves the line between fortress and sanctuary. Its design is a direct architectural homage to the Church of the Holy Sepulchre in Jerusalem, immediately connecting this Portuguese outpost to the spiritual heart of their order. The interior is a two-story marvel, the lower level for the sergeants and lay brothers, the upper level, richly decorated with painted statues and gilded woodwork, reserved for the Knight brothers. This circular design, bathed in the light from its central oculus, creates a powerful sense of unity and contemplation, a spiritual vortex within the martial shell of the castle. But the Templar engineers ensured this beautiful symbolism was backed by brute structural strength. The entire rotunda is supported by a massive central pillar, a stone trunk from which the delicate ribs of the vaulting spread outward. And here we find their signature innovation, iron. Embedded within the masonry are iron bars and cramps, acting as hidden tendons that lock the stonework together, counteracting the immense outward thrust of the dome and ensuring its perfect stability for centuries. This is the Templar philosophy in microcosm, a profound spiritual vision made physically possible and enduring by the most advanced civil engineering of its age. At Thoma, the warrior, the monk, and the master builder are not separate entities. They are a single, harmonious identity, forever frozen in stone. Now, this brings us to a fascinating and hotly debated question in architectural history. Were the Knights Templar true pioneers of the Gothic style, or were they simply savvy early adopters who recognized a good idea when they saw one? To answer this, we need to step away from their fortresses and into their sacred spaces, where the evidence for their innovative spirit is etched into the very stone. The classic image of Gothic architecture, soaring heights, vast windows of stained glass, and a delicate skeletal structure of stone, feels like a world away from the robust, muscular Romanesque style that dominated Europe when the Templars were founded. Yet, it was within their own unique buildings that many of these revolutionary ideas were being quietly tested and refined, long before they became the signature of Europe's great cathedral workshops. Consider the ribbed vault, one of the fundamental engineering breakthroughs that made Gothic architecture possible. Instead of a solid, heavy ceiling of masonry, a ribbed vault uses a skeleton of arched stone ribs to support a thinner, lighter web of infill. This concentrates the weight onto specific points, allowing the walls in between to be opened up and filled with glass. While the famous Abbey of Saint Denis in France, consecrated in 1144, is often credited as the first fully Gothic structure, evidence suggests the Templars were experimenting with similar concepts in their own buildings around the same time. Their chapel at Laon in France, for instance, features some of the earliest known ribbed vaulting, a daring experiment that demonstrated a clear understanding of how to redistribute structural loads for both strength and beauty. Then there's the pointed arch, another hallmark of the style. While its origins are deeply rooted in Islamic architecture, which the Templars encountered extensively in the Holy Land, they were among the first in Europe to grasp its structural superiority over the rounded Romanesque arch. The pointed arch directs weight more vertically downward, reducing the outward thrust on the walls and requiring less massive buttressing. This allowed for taller, more elegant structures. In their network of round churches across Europe, like the Temple Church in London, we see a fascinating hybrid. The overall plan is Romanesque and circular, but the interior arches are distinctly pointed, creating a lighter, more vertical emphasis that feels like a clear step toward the Gothic aesthetic. Perhaps the most compelling argument for their pioneering role lies in their use of what we might call proto-flying buttresses. The flying buttress is the iconic external armature of a Gothic cathedral, a stone arm that leaps through the air to channel the thrust of the vault away from the wall to an external pier. It's the exoskeleton that makes the glass walls possible. While the Templars may not have built the fully developed, graceful arcs seen at Chartres, they were certainly engineering solutions that served the same purpose. At their fortress of Thoma, the massive central pillar of the Charola and the thick surrounding walls act as an internalized buttressing system, absorbing all the forces within the structure itself. In other buildings, they used thicker, more substantial external buttresses in ways that clearly prefigure the later, more refined Gothic solutions. They understood the problem of thrust, and they were actively developing the architectural vocabulary to solve it. So, were they pioneers or followers? The most accurate answer is likely both. They were not working in a vacuum. They were brilliant synthesizers, absorbing ideas from the advanced Islamic and Byzantine architecture they saw daily and fearlessly adapting them to their own needs. They may not have invented the ribbed vault or the pointed arch, but they were undoubtedly among its most early and influential European practitioners. Their role was less that of the solitary genius inventor and more that of the crucial conduit and experimental workshop. They provided a safe space, funded by their immense wealth, for these radical Eastern ideas to be tested, adapted, and integrated into the European architectural tradition. By the time the great cathedral building boom of the 12th and 13th centuries began, the Templars had already been quietly building the future for decades, their chapels and commanderies serving as a living laboratory for the structural principles that would define an age. Their legacy in Gothic architecture is not a signature on a blueprint, but rather the deep, foundational work of the engineers who first dared to make stone seem to float on light. But to truly grasp the scale of their building achievements, we must step inside the forges where their most fundamental tools were born, the workshops of the Templar blacksmiths. Here, amidst the roar of the bellows and the ringing of hammer on anvil, the order's mastery of iron was refined into an art form, a suite of metallurgical secrets that gave them a tangible edge over every contemporary builder. Their smiths were not mere laborers. They were highly skilled technicians, alchemists of metal who understood that the difference between a good tool and a great one could shave years off a construction project. While others were content with wrought iron that was soft and prone to bending, or cast iron that was brittle and shattered under stress, the Templars pursued the perfect balance of strength and flexibility through advanced techniques like quenching, tempering, and careful alloying. The process began with the quality of their raw materials. Their vast network gave them access to some of the finest iron ore deposits in Europe, particularly rich sources in the regions of Lorraine and Normandy. But their genius lay in the subsequent treatment, quenching the act of heating steel to a critical temperature and then rapidly cooling it by plunging it into water or oil would harden the metal dramatically. However, a blade or a chisel hardened by quenching alone would be as brittle as glass, liable to snap on first impact. This is where the Templar smiths demonstrated their sophisticated understanding. They would then carefully reheat the hardened metal to a much lower temperature in a process called tempering. This subtle reheating relieved the internal stresses caused by quenching, trading a small amount of that extreme hardness for a great deal of toughness and resilience. The precise temperature and duration of this tempering process were the true secrets of the craft, knowledge passed down from master to apprentice that transformed a piece of hardened metal into a durable, reliable tool capable of holding a keen edge through hours of punishing work on hard stone. There is strong historical and archaeological reason to believe they didn't develop these methods in a vacuum. The Islamic world, particularly in centers like Damascus and Toledo, was centuries ahead of Europe in metallurgy, producing legendary blades of folded steel that were both razor-sharp and incredibly strong. The Templars, stationed in the heart of the Levant, would have had direct access to these superior weapons and tools, not just as users but as keen observers. It is almost certain that they actively sought out this knowledge, perhaps even employing or consulting with Muslim metalworkers to reverse engineer and adopt these advanced smithing techniques. This cross-cultural exchange wasn't about copying a sword design. It was about understanding the underlying science of carbon content, heat control, and molecular structure, a transfer of technical knowledge that supercharged their own industrial capabilities. The impact of this metallurgical mastery rippled far beyond the forge. In construction, a Templar mason armed with a tempered steel chisel could carve intricate details and shape hard stone with a precision and speed that was simply impossible with inferior tools. Their iron drills, hardened to perfection, could bore deeper and faster into bedrock for foundations or well shafts, but the applications extended into every facet of their operation. In agriculture, their advanced iron plowshares, tipped with hardened steel, could cut through tough, root-filled soil that would break or blunt a conventional plow. This allowed them to bring more land under cultivation faster, increasing the agricultural output that funded their entire enterprise. For transportation, the iron tires on their cartwheels, the nails holding their ships together, and the fittings for their harnesses were all forged to a higher standard of durability, reducing breakdowns and improving the reliability of their vast logistical network that stretched across continents. This hidden advantage in metalworking was a silent force multiplier, making every brother, every ox cart, and every construction site exponentially more efficient. Their mastery of metal wasn't just about building stronger walls. It was about building a stronger, more resilient, and more productive organization from the ground up. While we often picture the master mason on the scaffold or the blacksmith at his forge, the true engine behind the Templars' monumental building projects was an innovation far less visible but equally revolutionary: a logistical and supply chain network of breathtaking complexity and efficiency. Imagine the challenge of constructing a fortress like Shaytau Pelerin, which required thousands of tons of specific types of stone, vast quantities of high-quality iron, enormous timber beams, and specialized materials like quicklime for mortar, all in a remote coastal location in the Holy Land. For a king or a local lord, this would be a lifetime's endeavor, plagued by delays and shortages. For the Templars, it was a manageable operation, executed with a precision that would be impressive even by modern standards. Their secret was a system that turned their entire international presence into a synchronized supply machine, where a commandery in rural England could directly contribute to the strength of a wall in the Levant. The heart of this system was their network of commandaries. These were not isolated monasteries but functioning nodes in a vast, interconnected web. Each commandery had a dual purpose. It was both a local economic engine and a dedicated logistics hub. A preceptory in France's Champagne region, for instance, might specialize in generating revenue from its vineyards. That wealth, converted into silver, could be used to pay a team of expert quarrymen in Burgundy, known for their fine, durable limestone. The quarried stone wouldn't just sit in a yard. It would be loaded onto Templar-owned barges and floated down the Seine to a port like La Rochelle, where a Templar galley, part of their own significant fleet, was being loaded with supplies bound for Acre. This wasn't a haphazard collection of independent actions. It was a coordinated, continuous pipeline, with each link in the chain managed and financed internally by the Order. Their banking operations provided the ready capital to fund these long lead time projects, ensuring that work never stopped waiting for the next shipment. Managing the materials themselves required profound expertise. Stone wasn't just stone. The Templars understood the material properties of different types. They sought out dense limestone or hard granite for foundations and critical load-bearing elements, while using softer, more workable sandstone for intricate carvings and decorative features. This meant sourcing from specific, often distant, quarries renowned for their output. Timber presented another challenge. Giant oak beams for roof trusses had to be cut from mature trees, seasonally dried for years to prevent warping, and then transported, an enormous undertaking. The Templars often established dedicated woodland management programs near their major building sites, cultivating forests as a renewable resource, a practice far ahead of its time. And then there was iron. Their access to mines was strategic, but the real challenge was moving tons of ore to specialized smelting centers and then transporting the finished bars to the construction sites, all while protecting these valuable cargoes from theft or damage. This logistical prowess gave them an almost unstoppable advantage. While a secular ruler had to rely on feudal obligations, often convincing reluctant vassals to contribute resources or labor for a limited time, the Templars had direct, centralized control. They could plan decades in advance, secure in the knowledge that their income streams were reliable and their supply lines were their own. This allowed for a consistency of quality and pace that was unheard of. A mason at a Templar site could be confident that the next shipment of stone would match the last in dimensions and quality, enabling him to work faster and with greater precision. This administrative brilliance, often overshadowed by their military and architectural feats, was the silent, indispensable foundation upon which all their engineering miracles were built. It was the ability to move mountains, literally and figuratively, that truly set them apart. Yet while their castles and churches stand as their most visible legacy, some of the Templars' most profound and lasting innovations were cultivated not in stone but in soil. Beyond the battlements and the banking halls, the order managed a vast, sprawling empire of agricultural estates known as granges, and it was here that they applied their engineering mindset to the very foundation of medieval life, farming. This was not a side project. It was a central pillar of their economic and operational strategy. To feed their massive network of warriors, monks, and support staff, they needed to revolutionize productivity, and they did so by treating the land itself as a complex system to be optimized, much like a fortress or a watermill. Their granges became living laboratories of agricultural innovation, transforming barren or marginal land into engines of plenty that would become the envy of Europe. The first and most physically demanding challenge was land reclamation. Much of the land gifted to them, particularly in frontier regions like parts of France, England, and Iberia, was considered untamable, thickly forested, choked with scrub, or prone to flooding. The Templars attacked this problem with the same systematic efficiency they applied to a siege. They deployed their superior Templar-forged iron tools, massive axes with tempered steel edges that could bite deep into hardwood, and heavy, iron-shod plows with reinforced shares capable of breaking through tough, root-filled soil that would break the wooden plows of their neighbors. This wasn't just a matter of having better hardware. It was a coordinated, large-scale operation. Teams of brothers and hired laborers, organized with military precision, would clear vast swaths of land, methodically rooting out trees and boulders, and drainage teams would dig extensive networks of ditches and canals to channel water away from waterlogged fields, effectively creating new, fertile farmland from what was once considered worthless. This ability to literally reshape the landscape allowed them to dramatically increase the amount of land under cultivation, providing the raw acreage needed for their ambitious farming experiments. On these newly cleared fields, the Templars implemented a sophisticated and systematic approach to crop management that was far ahead of common medieval practices. While most peasant farmers followed a simple two-field system, leaving half their land fallow each year to recover nutrients, the Templars pioneered an early three-field rotation system. They would divide their land into three sections. One would be planted with a winter crop like wheat or rye, a second with a spring crop like oats, barley, or legumes like peas and beans, and the third would be left fallow. The following year, they would rotate the crops. This system had multiple brilliant advantages. It only left 1/3 of the land fallow at any time, increasing the total yield by 50%. Furthermore, the inclusion of legumes was a masterstroke of biological engineering. Legumes have the unique ability to fix nitrogen from the air into the soil, effectively acting as a natural fertilizer that replenished the ground for the more nutrient-demanding cereal crops that would follow in the rotation. This careful, scientific management ensured the long-term health and sustainability of their soil, preventing the exhaustion that plagued less thoughtful farmers. Their engineering prowess truly shone in their mastery of water for irrigation. In drier regions like the Iberian Peninsula, they constructed complex networks of acequias gravity-fed irrigation channels that were meticulously graded to carry water from rivers or reservoirs directly to their fields. These were not simple ditches. They were carefully engineered canals with sluice gates and distribution points that allowed them to control the flow of water with precision, ensuring every field received its necessary share. This turned arid landscapes into productive farmland capable of supporting multiple harvests a year. In wetter climates, their drainage systems did the opposite, protecting crops from rot and ensuring the soil was workable. This hydraulic management extended to using water power to process their harvests. They built water mills not just for grinding grain into flour, but for fulling woolen cloth produced from their enormous flocks of sheep, and for operating trip hammers in forges, creating a vertically integrated industrial agricultural complex that maximized the value of every single resource they produced. The output from these model farms was staggering. A single Templar grange could produce thousands of bushels of grain annually, along with vast quantities of wool, wine, and other goods. This surplus did not just feed their own members, it became a primary source of their immense wealth. They sold these goods at local markets and exported them through their own networks, generating a continuous stream of revenue that was every bit as important as banking or donations. More importantly, this agricultural abundance provided the fundamental stability that allowed all their other activities to flourish. A well-fed army is an effective army. A well-supplied commandery can withstand a siege. A wealthy order can fund ambitious construction. The Templars understood this chain of causality better than anyone. Their agricultural revolution reveals the holistic, systemic nature of their thinking. They were not just warriors, bankers, or builders. They were master systems engineers who understood that true, lasting power was built on the most fundamental of foundations: the ability to reliably feed oneself and generate wealth from the land. This often overlooked legacy in farming may be their most practical lesson, demonstrating that innovation is not always about grandeur, but about the intelligent, relentless pursuit of efficiency and sustainability in every aspect of life. Of course, a castle is only as strong as its ability to withstand an assault, and for the Knights Templar, this wasn't a theoretical exercise, it was a daily reality on the violent frontiers of the Crusader states. Their very survival depended on their ability to outthink and out-engineer their adversaries, and in doing so, they revolutionized the dark art of medieval defensive warfare. They approached a siege not as a simple contest of strength, but as a complex puzzle of physics, psychology, and brutal efficiency. Every element of their fortresses, from the grand overall plan down to the smallest detail in a gatehouse, was meticulously designed with one chilling purpose: to make the cost of attack unbearably high for any enemy foolish enough to try. Their most iconic contribution was the perfection of the concentric castle, a design so formidable it represented a quantum leap in military architecture. Imagine not one, but two complete rings of towering stone walls, one nested inside the other. This wasn't just about having a backup line of defense, it was a devastatingly clever trap. An attacking force that miraculously breached the outer wall didn't find themselves in the castle courtyard. They found themselves in a nightmarish killing zone known as the Outer Bailey, trapped between the two walls and completely exposed to a withering crossfire from the higher inner defenses. Archers and crossbowmen on the inner ramparts could shoot down into this crowded pen with impunity, while the attackers, now squeezed into a confined space, had their options severely limited. They couldn't effectively storm the inner wall because they were being attacked from above and behind, and retreating back through the breached outer gate was likely impossible. This design effectively turned the momentum of a successful breach against the attackers themselves, transforming their greatest achievement into their greatest vulnerability. The Templar fortress of Shaytau Pelerin was a masterclass in this concentric principle, its daunting double walls a silent warning to any army contemplating an assault. But the true genius of Templar defense lay in the chilling details, the macabre innovations designed to inflict maximum carnage at every step of an assault. Take the humble doorway. For most, it's a point of entry. For the Templars, it was the centerpiece of a multi-layered death trap known as the gatehouse. The main gate itself was rarely a simple wooden door. It was often a massive iron-reinforced portcullis, a grid of sharpened iron bars that could be dropped instantly from above to seal the entrance, and behind it, a second set of equally stout doors. The approach to this gate was usually a narrow, exposed corridor forcing attackers to bunch together, and above them, in the ceiling of the gate passage, were the infamous murder holes. These weren't just random holes in the floor. They were strategic openings through which defenders could rain down a horrifying assortment of projectiles on the trapped men below. Boiling water, hot sand that could seep through armor and cause agonizing burns, quicklime, and of course, arrows all poured down from a position of complete safety. The very architecture was weaponized, designed to break the enemy's spirit before they even reached the main battle. This relentless innovation extended to every surface of the castle. The tops of walls were punctuated by crenellations, the classic alternating high merlons and low embrasures that provided defenders with protected positions to shoot from. But the Templars often enhanced these with wooden hoardings, temporary wooden galleries that projected out from the top of the wall. These structures had holes in their floors, allowing defenders to stand directly above the base of the wall and drop stones or pour liquids straight down on sappers trying to undermine the foundations, eliminating the deadly blind spot at the very foot of the castle. Even the staircases within their keeps were engineered for defense, almost always twisting in a tight clockwise spiral. This meant an attacker climbing the stairs, sword in his right hand, would have his weapon arm cramped against the central stone newel post, while a defender descending had his right arm free to swing in the wide outer arc of the steps. It was a subtle psychological and physical advantage built right into the fabric of the building, and underpinning all of this stone and timber was once again their strategic use of iron. Those formidable portcullises were made possible by their metallurgical skill, forged into heavy, interlocking grids that could withstand tremendous force. The hinges and brackets for the massive gates were wrought iron, vastly stronger than their wooden counterparts, iron bands reinforced doors against battering rams, and iron chains were used in the sophisticated counterweight mechanisms for drawbridges. This integration of metal was the critical, hidden component that gave their defensive structures their legendary resilience. Their castles were more than just piles of rock. They were complex, interconnected machines for protection, each element working in concert to demoralize, channel, and ultimately destroy an enemy. They understood that the best defense was not just a high wall, but an intelligent one, and their innovations saved countless lives by making their sanctuaries virtually impregnable. Yet for all their brilliance in stone, iron, and logistics, the Knights Templar faced an enemy no castle wall could ever withstand: the calculated greed and political fear of a king. The dawn of the 14th century saw their world unravel with shocking speed. King Philip IV of France, deeply in debt to the order and covetous of their immense wealth and power, orchestrated one of history's most infamous acts of political treachery. On Friday, October the 13th, 1307, he launched a coordinated dawn raid across France, arresting hundreds of Templars, including the Grand Master Jacques de Molay, on a series of fabricated charges. What followed was a 7-year campaign of propaganda, torture, and show trials, culminating in the order's formal dissolution by Pope Clement V in 1312 under immense pressure from the French crown. Their assets were officially transferred to another military order, the Knights Hospitaller, though much was simply seized by secular rulers like Philip. The Templars as an organization were erased, but what becomes of knowledge when its keepers are silenced? This is where the story takes a fascinating turn. While the order itself was dismantled, its engineering legacy was far too valuable to simply vanish. It did not die with the last Templar. Instead, it underwent a great dispersal, seeping into the very foundations of medieval and Renaissance Europe. The most direct beneficiaries were other military orders, particularly the Hospitallers, who inherited not just Templar properties but also their operational blueprints. Suddenly in possession of formidable castles like Thoma and vast networks of commanderies, the Hospitallers had every incentive to maintain and even expand upon the sophisticated water systems, iron-reinforced masonry, and agricultural innovations they now owned. They became the new custodians of this technical knowledge, ensuring its survival and continued application. Perhaps more significantly, the Dissolution unleashed a wave of highly skilled, now masterless craftsmen onto the market. The Templars' master masons, blacksmiths, and hydraulic engineers did not simply disappear. They sought new employment, taking their hard-won expertise with them. Many found work with the very secular rulers who had suppressed the order, or with the church, which was embarking on its great age of cathedral building. Imagine a master mason, trained in the Templar practice of embedding iron bars within vaults to allow for wider spans, now applying that same technique to the construction of a new civic building or a bishop's palace. A blacksmith, versed in the Templar secrets of tempering steel to create superior tools, might now sell his services to a royal armory or a private mining concern. This diaspora of talent acted as a forced but incredibly effective knowledge transfer, seeding Templar innovations far and wide. We can see this legacy most clearly in the architectural flowering that followed. The principles of the ribbed vault and the pointed arch, which the Templars had so effectively pioneered and popularized, became the absolute cornerstones of the radiant Gothic style that swept across Europe in the 14th and 15th centuries. The great cathedrals that rose after their fall stand as monuments to engineering concepts the Templars had helped test and refine. Furthermore, their logistical and administrative model, the idea of managing a vast, international network of productive estates with centralized planning and quality control provided a powerful template for the emerging nation-states of Europe. Kings looking to consolidate their own power and finance their own building projects saw in the Templar system a blueprint for efficient, large-scale organization. So, while the name Templar was scourged from official records and their brotherhood was broken, their intellectual inheritance proved indestructible. It was broken down into its component parts and absorbed by the world that had rejected it. Their engineering philosophy, a blend of pragmatic efficiency, cross-cultural borrowing, and a willingness to experiment quietly became standard practice. The very stones of their castles, which continued to stand impregnable long after their banners were taken down, served as a perpetual, silent lesson in how to build for the ages. Their downfall was a human tragedy, but it was not the end of their story. It was merely the moment their innovations were released from the confines of a single order to begin their long, quiet work of shaping the modern world. It might seem like a leap to connect a medieval military order to the sleek skyscrapers and vast bridges of our modern world, but the philosophical through line is remarkably strong. The Templars' core engineering principles, durability, efficiency, and a holistic systems approach are not just historical curiosities, they are the very bedrock of contemporary civil engineering. Their most direct legacy is perhaps the most fundamental, the concept of composite materials. When those Templar masons embedded twisted iron bars within their stone arches to counteract tensile forces, they were engaging in a primitive form of what we now call reinforced concrete. They understood the fundamental weakness of masonry, its inability to handle bending or stretching forces, and they used the superior tensile strength of forged iron to compensate. Today, we do the exact same thing on a colossal scale, embedding steel rebar within concrete to create a material that combines concrete's immense compressive strength with steel's ability to resist tension. The materials have evolved, but the core principle of combining substances to create a stronger whole is a concept the Templars were mastering 8 centuries ago. This pursuit of durability is another powerful echo across the centuries. The Templars built with a long-term perspective that is increasingly relevant today. In an age of planned obsolescence, their structures stand for hundreds of years, not through magic, but through intelligent design and superior material science. Modern engineers fighting the costly battle against crumbling infrastructure can look to the Templars' meticulous site selection, their advanced mortar formulas that have resisted saltwater erosion for centuries, and their strategic use of specific stones for specific structural roles. Their approach was the antithesis of short-term thinking. They invested immense resources upfront to avoid catastrophic failure later. This is a powerful lesson in life cycle costing, a modern engineering concept that evaluates the total cost of a structure over its entire life, not just its initial construction. The Templars intuitively knew that building better, even if it was more expensive initially, was far cheaper than constant repair and rebuilding. Perhaps their most profound and prescient lesson is in the area of sustainability and adaptive design. The Templars were masters of working with their environment, not against it. Their sophisticated water management systems, which collected every precious drop of rainwater in cisterns and used gravity-fed channels for irrigation and industry, are models of resource efficiency. They designed closed-loop systems where waste from one process, like animal husbandry, became input for another, like fertilizing fields. They tailored their designs to local climates, using thick walls and small windows for insulation in some regions and clever ventilation systems for cooling in others. This is not so different from the goals of modern sustainable architecture, which seeks to minimize energy consumption, harness natural resources like sunlight and rainwater, and reduce the environmental footprint of construction. The Templars' commanderies were essentially self-sufficient, resilient ecosystems, a concept that is at the heart of today's most ambitious green building projects and the push for carbon-neutral cities. Finally, their logistical genius prefigured modern supply chain management and project planning, coordinating the movement of specialized stone from quarries in France, iron from mines in Germany, and timber from managed forests to a construction site in the Holy Land required a level of organization and communication that was unparalleled in the medieval world. This mirrors the complex global supply chains that bring together raw materials, prefabricated components, and specialized labor to build a modern airport or high-speed rail network. The Templars' ability to plan projects decades in advance, funded by their sophisticated financial systems, is a precursor to the modern concept of program management, where multiple interrelated projects are coordinated to achieve a larger strategic goal. Their legacy, therefore, is not found in a single patented technology, but in a timeless mindset, a relentless drive to solve practical problems with intelligent, resilient, and efficient solutions that are built to last. They remind us that the highest form of engineering is not just about overcoming the laws of physics, but about harmonizing with them to create a lasting and purposeful legacy. However, the sheer scale and sophistication of their achievements inevitably spawned a shadow world of myth and legend, a fog of conspiracy and speculation that often obscures the brilliant, practical reality of who they were. It is time to separate the historical truth from the tantalizing fiction, to clear away the romanticized mist and see the Templars not as mystical guardians of ancient secrets, but as the pragmatic, resourceful, and brilliantly organized engineers they truly were. One of the most persistent and alluring myths is that they discovered some profound, esoteric knowledge beneath the Temple Mount in Jerusalem, perhaps the Ark of the Covenant, the Holy Grail, or cryptic scrolls containing lost wisdom. This legend suggests their sudden rise to power and technological prowess was fueled not by hard work and smart borrowing, but by access to a supernatural or divine source of power. The reality is far more impressive because it is humanly achievable. Their secret knowledge wasn't a single mystical blueprint. It was the accumulated technical know-how of the known world, diligently gathered through their unique position at the crossroads of Europe and the Middle East. They didn't find a magic relic, they found better ways to build arches by studying Arabic architecture. They didn't decode an alchemical text, they mastered superior iron smithing techniques through observation and trade with Islamic metalworkers. Their genius was in synthesis, not supernatural discovery. Another common misconception paints them as sole, isolated geniuses, inventing revolutionary techniques from whole cloth. This ignores the fundamental nature of medieval technology, which advanced through the slow, collaborative sharing and improvement of ideas across cultures and generations. The Templars were not the only innovators of their time. They were part of a wider ecosystem that included the Cistercian monks, renowned for their own architectural advances, and the skilled Byzantine and Arab engineers they encountered. Their role was often that of the early adopter and perfecter, not the original inventor. They saw a pointed arch in a Muslim palace, understood its structural advantage over a rounded Romanesque one, and had the resources and ambition to implement it on a grand scale back home. They were the medieval equivalent of a cutting-edge tech company that excels not by inventing the microchip, but by brilliantly integrating existing technologies into a revolutionary new product. The most damaging myth perpetuated by their accusers and later romanticized in fiction is that their power was rooted in occult practices or heretical beliefs. This fantasy suggests their buildings stand because of some enchanted ritual, their mortar mixed with whispered incantations. This not only diminishes their actual skill, but completely misunderstands their core identity. They were first and foremost devout Catholic monks, their lives governed by a strict religious rule. Their engineering was an extension of their faith, a practical devotion to creating strong, safe, and self-sufficient houses for God and their brothers. The precision in their geometry was not for casting spells, but for creating structures that reflected the divine harmony they believed governed the universe. The longevity of their buildings is a testament to good physics, superior materials, and meticulous craftsmanship, not magic. By letting go of these seductive legends, we can finally appreciate the true, and in many ways more remarkable, nature of their accomplishments. Their story is not one of hidden treasures and magical powers, but one of immense organizational skill, relentless curiosity, and a breathtakingly modern willingness to learn from other cultures. It is the story of an organization that leveraged its wealth to fund large-scale experiments, that managed a global logistics network with stunning efficiency, and that embedded a culture of continuous improvement into everything it did. Their legacy is not a cryptic map or an unsolved code. It is written in the enduring stone of Thoma, the clever hydraulics of Shaytau Pelerin, and the innovative ironwork that held it all together. Understanding this reality doesn't make their story less compelling. It makes it more inspiring. It proves that humanity, through intelligence, observation, and collaboration, is capable of achieving the extraordinary, turning the raw materials of the earth into legacies that truly stand the test of time. Beneath the formidable walls and pragmatic fortifications, the Templars operated with a hidden intellectual compass, a profound belief that the universe itself was constructed according to divine mathematical principles. This wasn't merely an abstract philosophy, it was a practical design manual etched into the very stones of their buildings. They saw geometry not as a dry academic exercise, but as the sacred language of creation, a way to imbue their structures with both unshakable stability and spiritual resonance. This fusion of the rational and the mystical in their design process is what truly set their architecture apart from the purely utilitarian military architecture of their peers. For them, a perfectly proportioned arch was not just strong, it was a prayer, a physical echo of the harmony they believed governed the cosmos. This devotion to sacred geometry is most vividly expressed in their obsession with specific, powerful shapes, particularly the circle and the octagon. The circle, with no beginning and no end, was the ultimate symbol of God's perfection, eternity, and the heavenly realm. This is why their most sacred spaces, their rotunda churches like the famous Charola in Thoma or the Temple Church in London, are circular. This was a direct and deliberate architectural reference to the Church of the Holy Sepulchre in Jerusalem, physically connecting every Templar chapel across Europe to the spiritual heart of their order in the Holy Land. But the circle was more than just symbolism. It was also a structurally sound form, distributing stresses evenly, a perfect marriage of spiritual intent and engineering pragmatism. The octagon served as a bridge between the earthly and the divine, a shape mediating between the square, which represented the material world, and the perfect circle of heaven. Its 8 sides symbolized regeneration and resurrection, themes deeply meaningful to men who faced mortal danger daily. We see this shape repeated in chapter houses and baptisteries, a subtle geometric code reinforcing their core beliefs. The application of precise ratios, particularly the golden ratio or phi, elevates their work from mere construction to high art. This irrational number, approximately 1.618 to 1, appears repeatedly in nature, from the arrangement of leaves on a stem to the spiral of a nautilus shell. The ancients believed it represented a fundamental key to beauty and harmony, and the Templars integrated this proportion into their designs to create spaces that felt instinctively balanced and uplifting. While it's unlikely they used the complex decimal calculations of a modern mathematician, they employed practical geometric methods, perhaps using a compass and straightedge to generate the ratio through the division of lines and shapes. You can find its influence in the overall floor plans of their churches, where the length of the nave might relate to the width of the transept in a golden proportion, or in the intricate layout of a rose window, where the spaces between the stone tracery diminish according to this harmonic sequence. This wasn't done for aesthetic whimsy. It was a deliberate attempt to build a microcosm of God's perfectly ordered creation. Furthermore, evidence strongly suggests they aligned their structures with celestial events, weaving astronomy into their architectural tapestry. The orientation of their churches was meticulously planned, with the altar almost always facing due east toward the rising sun and Jerusalem, but some investigations point to even more precise alignments. A specific window in a commandery chapel might be positioned so that a beam of sunlight illuminates a particular carving or altar only on the summer solstice, the longest day of the year. Or the main axis of a building might align with the sunrise on the feast day of the saint to whom the chapel was dedicated. This celestial choreography transformed a static building into a dynamic instrument, a giant stone sundial and calendar that connected the worship within to the cyclical rhythms of the heavens above. It was a breathtakingly sophisticated way to demonstrate their belief that the divine order was reflected not just in scripture, but in the very movement of the stars and planets. This geometric rigor provided a common design language that ensured consistency and quality across their vast international network. A master mason arriving from a commandery in France to work on a new project in Cyprus would have understood the same geometric principles and proportional systems as his counterpart from England. They worked from templates and patterns based on these universal shapes and ratios, which allowed for a remarkable coherence in style and structural integrity, even when projects were separated by thousands of miles. This shared intellectual framework was the glue that held their architectural empire together, ensuring that a Templar building was instantly recognizable not just by its military features, but by its harmonious and intentional proportions. Their use of sacred geometry ultimately reveals the deepest layer of the Templar mindset, an unshakable conviction that to build with truth and beauty was to honor the divine architect of the universe himself, turning every stone they laid into a testament of their faith and their intellect. While their mastery of water in the Holy Land was a story of survival, back in Europe it became a powerful engine of economic domination. The Templars looked at a flowing river and saw far more than a natural resource. They saw a tireless, renewable source of mechanical energy that could be harnessed to generate immense wealth. Across their vast European estates, they became pioneers of medieval industry, constructing sophisticated water mills that did far more than just grind grain. These were not simple wooden structures. They were complex, multifunctional engines of production, and they became the beating heart of the Templar economic machine, transforming raw materials into valuable goods and revenue with relentless efficiency. The true genius of their milling operations lay in their industrial versatility. A single Templar mill complex on a strategically dammed river might house several different functions under one roof. One water wheel could power a set of millstones for grinding wheat into fine flour, the most basic and essential function. But right next to it, through a clever system of gears and axles, the same water flow could power a fulling mill. Fulling was a critical and labor-intensive step in cloth production, where woven wool was beaten and cleansed in a mixture of water, and fuller's earth to thicken and strengthen it. By mechanizing this process with trip hammers powered by water, the Templars could produce vast quantities of high-quality cloth at a fraction of the time and cost of their competitors. Other mills were dedicated to tanning leather, operating bellows for their forges, or even crushing oak bark for tannin. This vertical integration meant they could take a raw commodity like wool from their own enormous flocks and turn it into a finished, valuable product ready for market, capturing every bit of profit along the way. The engineering behind these mills was remarkably advanced, and once again, their command of iron was a critical factor. The core mechanisms, the axles, gears, and the shafts of the water wheels themselves were often reinforced or even entirely sheathed in wrought iron. This was a significant upgrade from the all-wooden components common in earlier mills. Iron gears meshed with greater precision and wore down far more slowly, transferring power more efficiently from the water wheel to the millstones or hammers. Iron axles could handle much greater torque and weight without snapping, allowing for larger, more powerful water wheels to be built. This use of metal components reduced downtime for repairs and maintenance, ensuring the mill could operate almost continuously, maximizing output and profitability. A Templar mill was simply built better and lasted longer, a testament to their understanding that superior engineering directly translated into economic advantage. Controlling these industrial hubs gave the order immense power and influence over local and regional economies. In an age where manorial lords often held a legal monopoly on milling, requiring peasants to use their mill and pay a portion of their grain as a fee, the Templars elevated this system to an industrial scale. By owning the most advanced and reliable mills in a region, they became the indispensable center of economic activity. Local farmers and craftsmen would bring their grain, wool, and other raw materials to the Templar mill because it worked faster and produced a better product. The fees and taxes collected from this processing became a steady and massive source of income. Furthermore, by producing surplus flour, cloth, and leather goods, they could feed and supply their own network of commanderies and garrisons while also selling the excess at market, generating even more capital. Their milling operations were not isolated money-makers. They were synergistic nodes that fueled their entire operation, from funding military campaigns in the east to bankrolling the next ambitious building project. The relentless turning of their water wheels quite literally powered the rise of their financial empire, proving that their most profound innovations were often those that harnessed the natural world to serve a vision of lasting power. This culture of collaboration extended far beyond a simple exchange of blueprints. It was a deep, symbiotic relationship rooted in a shared spiritual and practical worldview. The Cistercians, founded by Bernard of Clairvaux, who also wrote the influential rule for the Templars, were spiritual brothers in the truest sense. Their order was dedicated to an austere, disciplined life of prayer and manual labor, and they applied this rigorous mindset to their own building projects. While the Templars were mastering the art of military architecture, the Cistercians were revolutionizing ecclesiastical and monastic construction, pioneering the use of the pointed arch and the ribbed vault in their stark, beautiful abbeys that emphasized light and structural purity. Their approach was less about defense and more about creating an environment perfectly suited for contemplation and industry, yet the underlying engineering principles were strikingly similar. Both orders valued functionality, durability, and a kind of elegant simplicity, creating a common language that made collaboration not just possible, but incredibly fruitful. We can see this partnership come to life in the very stones of their buildings. A Templar commandery might be built near a Cistercian abbey, and the flow of ideas was often a two-way street. The Cistercians, with their vast agricultural expertise and sophisticated water management systems for their monasteries and mills, likely influenced the Templars' own highly efficient farming and hydraulic operations on their European estates. In return, the Templars, with their unique access to Eastern building techniques and their advanced metallurgical knowledge, could have provided the Cistercians with insights into stronger mortar formulas or more efficient ironworking for their tools and architectural fittings. There's compelling architectural evidence at certain sites, like the Abbey of Fontenay in France, where the clean, rational lines and early use of pointed arches show a design philosophy that the Templars would have recognized and admired, perhaps even adapting elements for their own more fortified structures. This wasn't a formal alliance with signed contracts, but an organic, continuous conversation between two of the most technologically advanced organizations of the Middle Ages. This spirit of knowledge sharing rippled out to other groups as well. The Templars maintained working relationships with the Knights Hospitaller, their fellow military order in the Holy Land, and though they were often rivals, they were also pragmatic colleagues who understood the value of shared survival techniques in a hostile environment. They would have exchanged crucial information on siege warfare, fortress design, and water conservation methods learned through brutal experience. Furthermore, through their banking and travel networks, the Templars acted as a bridge, connecting the innovations of monastic orders with the ambitions of secular rulers. A king wanting to build a new castle might hire a master mason who had trained on a Templar project, inadvertently importing their techniques. Or a Templar brother, traveling from a construction site in the Levant, might share observations about Arabic irrigation methods with a Benedictine monastery in Italy that was looking to improve its own fields. This created a vibrant pan-European ecosystem of innovation where breakthroughs didn't remain isolated secrets but were gradually disseminated, tested, and improved upon by a wide community of builders and engineers. The Templars' greatest role may not have been as solitary inventors, but as the medieval world's most effective and well-connected project managers, facilitators, and catalysts for technological progress, proving that the most enduring legacy is often built not in isolation, but through connection. For centuries, the full story of Templar engineering was shrouded not in conspiracy, but simply in time, buried under layers of soil and subsequent construction. The written records from the order itself are frustratingly sparse, lost to the chaos of their dissolution or deliberately destroyed. This is where the meticulous science of archaeology steps in, serving as our most reliable time machine, allowing us to peel back the earth and confront the physical truth of their innovations. Unlike speculative histories or romantic legends, the trowel and brush reveal an unambiguous narrative written in stone, mortar, and iron, providing the tangible, undeniable evidence that separates fact from folklore. Every excavation at a Templar site is like putting together a massive, three-dimensional puzzle, where each unearthed piece adds clarity to our understanding of their technical prowess. Take the ancient port city of Acre, the final capital of the Crusader Kingdom of Jerusalem and a major Templar stronghold. Excavations there have been nothing short of revolutionary. Archaeologists digging beneath the later Ottoman layers have uncovered the stunning remains of the Templar fortress, including its central keep and a vast, elaborately vaulted complex known as the Templar Tunnel. This underground passageway, stretching from the fortress to the port, is a masterpiece of military engineering, but its construction tells an even deeper story. Analysis of the masonry has revealed the extensive use of iron cramps and dowels to lock the massive ashlar blocks together. These weren't just occasional reinforcements, they were systematically deployed at critical stress points, proving that the Templars' use of metal in masonry was a deliberate, standardized engineering practice, not a sporadic experiment. Furthermore, sediment analysis in the tunnel's drainage channels shows a sophisticated understanding of hydraulics, designed to keep the passage dry even during the Mediterranean's winter rains. Across Europe, similar discoveries have echoed the findings in the Holy Land. In London, the restoration of the iconic Temple Church provided a rare opportunity for close archaeological scrutiny. While the church itself is well known, investigations into its foundations and fabric uncovered secrets hidden for 800 years. Using endoscopic cameras to peer inside the walls, engineers discovered iron tie rods embedded deep within the masonry, precisely placed to counteract the outward thrust of the soaring vaults. This was a eureka, a moment providing physical proof of a technique historians had only suspected from written accounts. Even more fascinating was the analysis of the mortar. Samples taken from between the stones were found to have a unique composition, including crushed terracotta and specific aggregates, which gave it exceptional durability and resistance to London's damp climate. This wasn't just mud and straw, it was a chemically engineered building material formulated for longevity. Modern technology has exponentially accelerated our ability to uncover these secrets without even lifting a trowel. Ground-penetrating radar and LiDAR light detection and ranging surveys are now indispensable tools. At commandery sites in the French countryside, these technologies have mapped extensive underground networks of drainage pipes, cellar complexes, and the foundations of long-vanished workshops and forges, revealing the true industrial scale of these operations. Magnetometry, which measures subtle variations in the Earth's magnetic field, has been used to detect the telltale signs of ancient hearths and metalworking areas, pinpointing where the Templars' superior iron was actually smithed and worked on site. This non-invasive archaeology allows us to see the entire layout of a commandery as an integrated system, understanding how water was channeled from a river to a mill, then to a tannery, and finally into irrigation channels for the fields, a complete cycle of sustainable production. Perhaps the most personal finds are the smallest ones, the everyday objects that speak to the human hands behind the grand designs. Archaeologists have uncovered the specialized tools of Templar craftsmen, heavily worn masons' chisels with tempered steel tips that outlasted their competitors, uniquely designed plumb bobs for perfect vertical alignment, and precision compasses for drafting their geometric designs. The discovery of a blacksmith slag pit reveals the quality of the ore they were working with and the efficiency of their furnaces. Even something as simple as a leather shoe, preserved in the waterlogged soil near a mill race, connects us to the individual brother who operated that machinery. These artifacts collectively paint a picture not of mystical architects, but of a highly organized, resource-rich, and technically proficient organization that valued quality tools and skilled labor above all else. Each fragment of iron, each carefully laid stone, and each cleverly engineered water channel, when read by a skilled archaeologist, adds another verse to the epic poem of Templar engineering, proving that their greatest legacy was not written on parchment, but embedded in the very earth beneath our feet. While their formidable castles were designed to control territory and withstand assault, the Templars understood that true power also flowed along the roads and rivers that connected the medieval world. This insight led them to become master builders of a different kind of structure, the bridge. Far from simple crossings, their bridges were strategic infrastructure projects that showcased their civil engineering prowess in a new light, transforming them from isolated fortress dwellers into architects of connectivity. In an era where a river could be as effective a barrier as any wall, the Templars used their unique skills to tame these waterways, creating durable, reliable links that strengthened the economic and military networks they depended on. A well-built bridge did more than just allow passage. It accelerated trade, enabled rapid movement of troops, and brought remote communities into a larger, more prosperous system, all while generating valuable income from tolls. This venture into bridge building reveals yet another dimension of their genius, demonstrating how their engineering mindset was applied to open up the landscape rather than close it off. The challenges of building a lasting medieval bridge were immense. A structure had to withstand not only the constant, erosive flow of water, but also the destructive force of seasonal floods, ice, and the heavy loads of carts, livestock, and people. The Templars approached this problem with their characteristic blend of borrowed knowledge and practical innovation. While the basic Roman design of stone piers supporting a deck was well known, the Templars enhanced it significantly with their masterful use of iron. They employed massive iron clamps, known as cramps, to lock the large stone blocks of the piers together underwater, creating a monolithic strength that could resist the current's relentless tugging. Above the waterline, they used iron tie rods and chains to reinforce the stone arches, counteracting the lateral forces and ensuring the structure remained stable under load. This strategic incorporation of metal was their signature contribution, turning a potentially vulnerable crossing into a monument of durability that could serve for centuries. Perhaps no example is more legendary, though shrouded in mystery, than the incredible bridge at Puente del Inca high in the Argentine Andes. While its construction post dates the Templars and is attributed to natural mineral deposits, its name and enduring myth speak to a powerful and persistent legend of their skill. The story tells of a great Inca emperor whose son was gravely ill. His army, desperate to reach the healing hot springs on the other side of a raging mountain river, was unable to cross. As they prayed for a miracle, the very gods answered, causing the mountain to collapse and form a natural stone bridge overnight, allowing the army to save the prince. Centuries later, Spanish colonists witnessed this massive, seemingly impossible stone arch and, unable to explain its perfection, attributed its construction not to Inca engineers or nature, but to the only organization they believed capable of such a feat, the Knights Templar. They named it Puente del Inca, the Inca's bridge, but the underlying belief was that such a marvel of engineering in a hostile, remote environment could only be the work of the legendary warrior monks. This folklore, however historically inaccurate, is a powerful testament to the lasting reputation of Templar engineering. It cemented their image in the popular imagination as the only builders capable of performing miracles in stone, their legend so potent that it traversed oceans and centuries to explain the unexplainable. Back in the more documented world of Europe and the Holy Land, their bridges played a crucial role in their logistical and economic system. A prime example is the bridge they are believed to have built or maintained at the town of Ramla, a key junction on the road between Jerusalem and the port of Jaffa. Controlling this crossing meant controlling the flow of pilgrims, goods, and military supplies along one of the most vital arteries in the region. The tolls collected from merchants and travelers provided a steady stream of revenue, while the ability to move their own troops and resources quickly was a significant military advantage. In Europe, their commandaries were often situated near important river crossings, and they frequently took on the responsibility of maintaining the bridges, ensuring these critical links remained open. This was not purely altruistic. It was a calculated strategy that reinforced their role as indispensable facilitators of commerce and travel, weaving their order into the very fabric of daily medieval life and enhancing their influence far beyond the walls of their castles. Ultimately, these projects complete our picture of the Templars not just as warriors or bankers, but as holistic civil engineers. Their legacy is found not only in the defensive might of a crack des Chevaliers, but also in the quiet, enduring strength of a stone bridge that connected communities. They built to defend, but they also built to connect. They constructed barriers against their enemies, but they also forged links for their allies, for commerce, and for the pilgrims they were sworn to protect. This dual nature is the essence of their engineering philosophy, an understanding that true strength lies in both resilience and connectivity, in the fortress that withstands a siege and the bridge that welcomes trade. Their work on these vital arteries of the medieval world proves that their greatest construction was not any single building, but the vast, interconnected network of power, faith, and innovation they built across continents, a network that, much like their strongest bridges, was designed to endure. So, with all this incredible innovation, one can't help but wonder, where did they formally teach all of this? Did the Knights Templar run secret engineering schools, perhaps hidden within their commanderies, complete with classrooms and textbooks on advanced masonry? The romantic image is compelling, but the reality, as uncovered by historians, is far more pragmatic and in many ways even more impressive. There is no archaeological evidence or historical document that points to a formal Templar University of Civil Engineering. They did not grant degrees or keep rigid academic curricula. Instead, their entire vast network of commanderies, building sites, and workshops was the school. Education was not a separate activity. It was fully integrated into the daily life and mission of the order, a continuous process of learning by doing, overseen by the most experienced masters. This hands-on apprenticeship model was the engine of their knowledge transfer, a young man joining the order, whether as a knight brother or more likely as a sergeant brother with a background in stonemasonry or blacksmithing, would not be sent to a lecture hall. He would be assigned to an active building project, perhaps the construction of a new chapel wing at a commandery or the repair of a fortified wall. His education would begin at the most fundamental level, under the watchful eye of a master craftsman. He would learn by first observing, then assisting, and finally executing tasks himself. A mason apprentice might start by mixing mortar to a specific, guarded formula, learning through feel and sight the precise consistency required. He would then graduate to dressing stone, mastering the use of those superior Templar forged chisels to shape blocks with the exact dimensions and angles needed for a complex vault. Only after years of this painstaking, practical training would he be trusted with the geometry and layout of a structure itself. This method ensured that techniques were not just understood theoretically, but were embodied as muscle memory and ingrained practical wisdom. The master craftsmen themselves were the living libraries of Templar engineering. These were highly skilled individuals, likely drawn from the best workshops across Europe and the Levant, attracted by the Order's vast resources and the unprecedented scale of their projects. They held the secrets of the trade, the precise temperature for tempering an iron drill bit, the exact proportions for the hydraulic mortar used in cisterns, the geometric rules for laying out a pointed arch. This knowledge was transmitted orally and through demonstration, a sacred trust passed from one generation of builders to the next within the closed world of the Order. This system also fostered a powerful culture of continuous improvement. On a remote building site in the Holy Land, a master mason might devise a clever solution to a structural problem presented by the local stone. That innovation, proven effective on the job, would then become part of the knowledge base carried by that master or his apprentices to the next project in Cyprus or France. Their classroom was the entire Mediterranean basin, and their textbooks were the enduring structures they left behind. This pragmatic approach to education guaranteed two crucial things: quality control and operational security. By training their own craftsmen internally, the Templars could maintain a consistently high standard across all their projects, from London to Jerusalem. Every brother understood the Templar way of building, creating a recognizable quality and style that transcended local traditions. Furthermore, it kept their most valuable technical secrets within the family. Their advanced metallurgical formulas, their mortar recipes, their techniques for iron reinforcement, these were competitive advantages that they had no interest in sharing with the outside world. This informal yet highly effective system of apprenticeship was the perfect knowledge transfer mechanism for a militant monastic order. It was disciplined, efficient, secretive, and produced tangible, magnificent results. It ensured that a brother knight overseeing a project in Portugal fundamentally understood the same principles of construction as a brother in charge of a fortress in the Levant, creating a unified engineering culture that was one of the greatest strengths of their incredible international empire. What truly set the Templars apart from every other medieval builder was their refusal to impose a single, rigid blueprint upon the world. They understood that engineering is not about mastering one set of rules, but about listening to the land itself, to its climate, its geology, and its unique challenges. A design that brought victory in the cool, misty forests of France would mean certain defeat in the blistering sun of the Levant. This profound respect for local conditions became their greatest strategic advantage, transforming them from mere builders into master adapters whose structures spoke the native language of the earth they stood upon. Their genius lay in a flexible playbook, one that prized intelligent response over rigid dogma, allowing them to construct enduring strongholds from the arid deserts of the Holy Land to the rain-lashed coastlines of Portugal. In the Near East, they faced an environment of extremes, scorching summer heat, torrential winter rains, and the ever-present threat of seismic activity. Their response was a masterclass in environmental engineering. Take their coastal fortress of Shaytau, Pelerin. Instead of fighting the Mediterranean climate, they embraced it. They oriented the castle to capture the prevailing sea breezes, designing intricate ventilation shafts within the massive walls that funneled cool air through living quarters and storage rooms, creating a natural air conditioning system that provided relief from the oppressive heat. For water, a matter of life and death in a siege, they became hydrological savants. The entire castle was designed as a massive rainwater harvesting system. Every rooftop, courtyard, and paved surface was subtly sloped to channel every precious drop of rainfall through a network of stone gutters and clay pipes into enormous underground cisterns carved directly into the bedrock. This wasn't just a few barrels. These were monumental, vaulted reservoirs that could hold millions of gallons, ensuring the garrison could withstand years of isolation. Furthermore, their masonry had to be resilient. In earthquake-prone regions, they employed flexible iron clamps and dowels to lock stone blocks together, allowing the structure to sway and settle during tremors without catastrophic collapse, an ancient form of seismic retrofitting that has kept their walls standing for centuries. When they built in the cooler, wetter climates of Northern Europe, their engineering priorities shifted dramatically. Here, the enemy was not sun, but damp and frost. In their commanderies across England and France, the design focused on warmth, dryness, and managing abundant water for industry rather than hoarding it for survival. Their buildings featured thicker walls not just for defense, but for insulation, retaining heat from massive fireplaces. They became experts in drainage, surrounding their complexes with deep ditches and constructing raised stone footings for granaries and storehouses to protect precious grain and goods from ground moisture and pests. Their mastery of water power reached its zenith here. They didn't just build mills, they engineered entire landscapes. They would divert rivers with carefully graded leats to ensure a consistent, powerful flow to the water wheels that powered their forges, fulling mills for cloth production and grain mills. This manipulation of water turned their European estates into industrial powerhouses, using the environment itself to drive the economic engine that funded their operations in the East. The same principles of water management were applied, but for entirely different purposes, one for conservation, the other for production. This incredible flexibility extended to the very materials they used. They were brilliant at sourcing locally available stone and timber, reducing transport costs and ensuring the materials were already acclimated to the local conditions. In the limestone regions of France, they built with beautiful, fine-grained ashlar. In the granite-rich areas of Portugal, they used the harder, more durable stone. Their mortar recipes were equally adaptable. Analysis of mortar from different sites shows they tweaked the formula based on local needs. In a maritime environment like Acre, they used a mix with added crushed pottery or volcanic ash to create a more hydraulic mortar resistant to saltwater erosion. Inland, they might use a different aggregate for better workability or frost resistance. This willingness to adapt their core recipes shows a scientific mindset that valued performance over tradition. They didn't have a single secret formula. They had a methodology for developing the right formula for the job at hand, a principle that is absolutely fundamental to modern materials science. This ability to listen to the whispers of the wind, the patterns of the rain, and the tremors of the earth, and to translate those whispers into stone and mortar, is their most enduring lesson for us today. But perhaps their most subtle and enduring influence can be found not in their isolated fortresses, but in the very way they organized the spaces where people lived, worked, and worshipped. The Templars' approach to urban planning, though often overshadowed by their military and financial exploits, reveals a sophisticated understanding of community, efficiency, and security that would quietly set a new standard for medieval town design. Their commanderies were not just solitary outposts. Many evolved into the nuclei of entirely new towns, while others were integrated into existing urban centers with a level of intentional design that was revolutionary for its time. These complexes were meticulously planned ecosystems, blending residential, commercial, agricultural, and spiritual functions into a cohesive and highly functional whole, creating a blueprint for urban living that balanced human needs with pragmatic order. Consider the layout of a typical major commandery in Europe, like the one at La Rochelle in France or Thoma in Portugal. Unlike the organic, often haphazard growth of a typical medieval town, which sprawled out from an old Roman core or a lord's castle in a tangled web of narrow alleys, the Templar precinct was a model of rational planning. The entire complex was usually arranged around a central courtyard, a design that harkened back to Roman military camps and echoed the cloisters of monastic orders. This open space served as the heart of the community, a place for assembly, market activity, and the mustering of men and goods. Radiating from this central hub were clearly defined zones: the sacred area with its chapel or church, the residential quarters for the knights and sergeants, the administrative buildings like the chapter house for meetings, and the extensive economic infrastructure including storerooms, stables, workshops, and granaries. This wasn't a random collection of buildings, it was a thoughtfully orchestrated layout where function dictated form. The forge, with its fire risk and noise, was situated downwind and away from the quiet dormitories. The granaries were built on raised stone staddles to protect the vital food supply from damp and rodents. The entire complex was often encircled by a strong wall, not just for defense, but to create a clear boundary between the disciplined world of the order and the chaos of the outside world, establishing a powerful sense of place and identity. This philosophy of integrated zoning extended beyond their own walls and into the towns that grew up around their influence. In places like Lyon in France, the Templars didn't just build a commandery, they actively shaped the urban fabric around it. They would plan and construct entire streets, ensuring they were wide enough for carts to pass and for light and air to circulate, a stark contrast to the dark, cramped lanes of most medieval cities. They understood the importance of infrastructure, building and maintaining bridges, roads, and water systems that served both their own needs and those of the surrounding populace. By controlling key points of transit and trade, they could effectively guide the growth of a city, fostering economic activity that benefited their own operations while also providing stability and security for local residents. Their presence often acted as a catalyst for urban development, attracting craftsmen, merchants, and settlers who sought the safety and economic opportunities that the Templar umbrella provided. The underlying principles of these designs, functionality, security, and community, were nothing short of revolutionary. Their prioritization of hygiene, for instance, was extraordinary for the era. The sophisticated water channels and drainage systems that ran through their commanderies weren't just for industry. They carried away waste and provided clean water, drastically reducing the risk of disease that plagued most medieval settlements. The open courtyards and planned streets allowed for better ventilation and sunlight, improving public health. Their emphasis on security, through strong gates and perimeter walls, created safe enclaves that protected not only wealth but also people, fostering a sense of communal safety that was a rare commodity in the Middle Ages. This holistic approach to planning, which considered the physical, economic, and spiritual well-being of the inhabitants, created a template for the ideal medieval community. It demonstrated that a well-organized space could directly produce a more productive, healthier, and more resilient society, a concept that would slowly filter into the consciousness of secular rulers and eventually influence the planned bastide towns of the later medieval period and beyond. The quiet order of a Templar commandery, therefore, stands as a profound and often overlooked legacy, a testament to their belief that true strength was built not just on strong walls, but on the foundation of a well-ordered community. So as the last stones were laid on their final commanderies and the last of their iron tools fell silent, what are we to make of the Knights Templar? Their story is often one of whispered secrets and lost treasures, but their true, enduring legacy is written not in cryptic maps, but in the very language of stone, water, and iron that still speaks to us across 8 centuries. They were not mystical guardians of occult knowledge, but something far more compelling. They were master synthesizers, brilliant systems thinkers, and pragmatic engineers who understood that true strength is built on a foundation of intelligent design. Their genius was in seeing connections where others saw only chaos, connecting the forge to the fortress, the river to the revenue, and the quarry to the chapel. They built a network of knowledge that stretched across continents, and in doing so, they quietly laid the groundwork for the world to come. The most powerful lesson they leave us with is one of breathtaking relevance today, the imperative of resilience and sustainability. In an age confronting climate change and resource scarcity, the Templars' approach feels startlingly modern. They didn't seek to dominate their environment, they sought a symbiosis with it. They looked at a sun-baked cliffside and saw a rainwater catchment system. They looked at a flowing river and saw a source of mechanical energy. They managed their agricultural lands not for maximum short-term yield, but for long-term fertility and abundance. Their entire operational philosophy was a closed-loop system where waste was minimized, resources were conserved, and every output was fed back into the system as an input. In an era we often dismiss as primitive, they were engineering for a future they would never see, building structures and systems designed to endure for centuries. That is the very definition of sustainable thinking. Ultimately, their story is a profound reminder that innovation is rarely a sudden, blinding flash of invention. More often, it is a slow, steady process of adaptation, of cross-cultural pollination, and of daring to combine old ideas in bold new ways. The Templars stood at a unique crossroads, and they had the wisdom to listen and learn from every culture they encountered. They took the pointed arch from Arabic architects, the ribbed vault from Byzantine builders, and the secrets of steel from Damascene smiths, and they fused these innovations with their own European traditions and their immense logistical power. Their greatest invention was not a single tool or technique, but a methodology, a relentless, practical, and holistic way of solving problems. They teach us that progress is built not by erasing the past, but by building upon it with courage and vision. Their legacy endures not in shadowy myth, but in the timeless principles of building well, thinking systematically, and daring to imagine a stronger, more connected, and more resilient world. Thank you for joining this journey into the past to uncover the engines of the future.